Dobrý večer. Škoda, že jste někteří tak daleko. Já už na vás ani skoro nezaostřím se přibývajícími léty. Jsem moc rád, že jste přišli, když už je poměrně pozdě. Máme za sebou dlouhý a perný den. Ještě to je taková přednáška podle toho názvu dost pro fajnšmekry, takže já mám na starost moderování této sekce a musím přiznat, že neumím k tomu příliš mnoho říci. Takže budu spíš poslouchat, budu doufat, že si něco přiučím. Není to můj šálek čaj, jak se říká, ale rád zjišťuju, co všechno existuje. Jo, protože je vidět, kolik toho je. Takže Karel Vlk z firmy SolarWinds a já moc děkuji, že jste přišel a máte svých 25 minut. Děkuji.
Dobrý večer. Good evening, gentlemen. There are no ladies tonight. My name is Karel Vlk. I am from SolarWinds company, and today I would like to talk about this topic, mostly SQL-based thing about scaling, maintaining our product. There are some differences against standard stuff, so maybe it will be beneficial for you to hear something about really big software. I know today quite late. Last session, everyone is sleepy, so it's not gonna be a Playboy late night. It will be SQL late night. So please try to look at all those. What is SolarWinds? We are no energy company. We have nothing to do with solar energy. We have nothing to do with wind energy. We are software developers. And what we do, we are delivering observability. Mostly the tools for IT professionals to for the overview of all the systems, hardware, software, anything what you can imagine. There is a very wide definition, so maybe it tells much more. But in common language, overview from the many points of view to give you the information you need for your decisions, for the automation, and for other stuff. Where to find here OLTP and OLAP? What we are doing? We have a reality with some devices, with some applications, and we are trying to collect data about it and to store that data efficiently, quickly into the database. We have cloud part, we have on-prem part. That's why this looks like hybrid schema. We have some services that are pulling data into, and this is the OLTP part. In defined intervals, we are collecting data about many, many devices, and the flow of the data is really huge. That's why this is very heavy OLTP, online transactional processing scenario. At the same time, we are doing also reporting and alerting based on the historical data. And this data is also huge, and that's the OLAP part, online analytical processing. We are processing big data queries. This is the really killing scenario where both these worlds meet. Usually you have the system that cares just about the data collection, and the part which analyzes the data is somewhere else, in the data warehouse or in a different database, in a different system. Here we have everything in one. We have very, very complex system with many interactions relations. What is the general characteristics? We are ingesting data 24/7 every day. There are no maintenance windows. The threads and operations are really concurrent. There are simultaneously running 5,000 sessions on the database side and sometimes even more. We have many different online consumers, services, users. We have some external API that might be consumed by programming languages, and the users might do their own stuff. Simultaneously, with all of this that is trying to do something with the data, we have something what is analyzing it online, offering reports, offering those alerts, and some automation around it. Even worse, customers may customize many things. For example, the biggest thing is the retention of data, because if you have default 7 days for the detailed data and someone changes it to 30, it has a huge impact on the system, and you need to count with that. I mentioned already, we have no maintenance window. So all the maintenance must be done on the background with all the services running. And that's quite killing scenario. And if you count into the fact that the customer is installing, managing, and owning the server itself and doing the installation of the SQL, because you are delivering box product. It's not a locally developed system where you can babysit everything what's there. It's quite challenging fact. With the availability groups and all the options that SQL Server can have, the complexity is even bigger. The database is surely a bottleneck. Here, very similar example, but with some APIs we have some direct queries, we have some services. This is not one service, but usually it's 10, or with the big installations, hundreds services, hundreds instances of services that are communicating with the database simultaneously. And the problem might be also the custom scripts, because you never know what customer executes, what they define, and how well it is written, what it might do with your system. We can say we have a SolarWinds ecosystem, because this system is really customizable and scalable. You can install it at one computer, or two computers, one database, one, let's say, we call it main polar, but you can have 20, 50 components, and each of them is part of the installation done separately. And everything is communicating with one point, and that's the database. We have a hybrid scenario where part of the data goes to the cloud. It's separated from what I will be talking about today. I'm talking mostly about the on-prem side, about the installed SQL somewhere, maybe in Azure, somewhere in the local center, doesn't matter. And also, we have multiple modules that customers may customize. They can choose what they want, if it's about applications, devices, networking, many things. And within the module, they can customize reports, widgets, settings, change a lot of things that is affecting the performance, data size, and all around the database. One of the open APIs is called Orion SDK. Already mentioned that it can be consumed by programming languages like Python, PowerShell. Some kind of automation may be done upon that. And that is not in our hands. So main differences between the box software and the local database is we have the same code for everything. If you install it as one component or 50 components, it's still the same code base. No difference there. And you need to count with all the situations I mentioned, with all that fine tunings and challenging parts. Every customer has a different setup, different system configuration, and very different system behavior. And it's quite hard to think about all the states where it might come into. A huge problem is third-party software interactions. If you imagine you have installed SQL Server that is managed by the customer, and they have another database, not yours, not SolarWinds, that is taking part of the load. Or they have some kind of sniffer software that is taking some data from it, trying to analyze the trends, that is deploying some database objects that might be interacting with your code, with your deployment. You can't troubleshoot anything online, like with the local system, and you need to wait for, let's say, customer issue if you do not cover that with tests. No access to the environment where you can do something now. You need to wait, you need to collect some data and wait for some analysis, what can be done. Even the thing that we are supporting all the SQLs, like on-premise installations, Azure, AWS, there are fine differences that are doing this stuff more complex, because there are differences. It's not the same. Maybe from the simple select point of view, it works very similar, but there are different DMVs, there are different settings, some things that you cannot change in Azure, etc. And even worse with the hardware and other software or SQL config itself, because it's not managed by us. Such thing as always-on availability groups might generate huge problems for you if you do not count with that option with the product. And it's just a simple thing in a connection string that is somewhere and database is using it. What interactions? One thing from the practice we encountered. For example, bug in Microsoft. SQL Server 2022 was released with a big bug. When you try to create memory-optimized file group, it was created without a relation to the storage. It didn't know about the folder where the files are. Currently, if you look at the web and download the RTM, it's fixed. I don't know how they did it, but it's fixed. But we have it reported from the customers, and we need to resolve such issues because the database was simply broken when we tried to upgrade. So if someone was using RTM, which I think is not the best option, better to wait for some cumulative update, not to work with what was released in production. We had a very terrible days with that. There was error with creating any memory-optimized objects, and we need to take care. Other things that might broke this feature, and I am talking about memory-optimized tables as one important feature for us that is helping us to improve the performance of the system, performance of the database. The thing that breaks it also are the third-party interactions with the server-level objects. If someone creates, for example, trigger that is trying to get the changes in the tables views, it will break it, because this is some limitation from the Microsoft side. We have not deployed it, but some third-party application did, or DBA of the customer. And it's another thing that simply breaks that. Or very weak hardware configuration, and you need to have some some backup. If it's not good enough to handle the memory-optimized technology, you need to deploy common tables instead, and work with two types of objects and with two types of deployment. The question, how can we get the details about the customer's problem if the database is not ours, when we can't connect there? Any ideas what you would use? We have a lot of information sources we can collect. We have something what we call diagnostics. It's a set of files we can generate from the customer's database, and we can ask them to do that and upload it for us. It contains logs, some samples of data, but it's not all. It contains just a point-in-time information, not the trend, not the overview of the system. So very hard to tackle anything in deep. We have an improvement program that tells us some details about the customer's setups, what hardware they have, how many components they are managing, collecting data about. Then some descriptions in Jira, Salesforce, but it's usually in very common language and will not help you very much. Online session with the customer is nice, but you need to wait for that. You need to be online with them, and if you need to analyze something, what is reported, you might hit the time frame when it happens, or you do not hit it, because it simply happens only sometimes. So it's quite hard. Or local environment repro. So the best of all is the monitoring data. Otherwise, you are looking into the crystal orb. You never know. If you have monitoring data, that's another word for the observability. You are fine, because you know what was all around the system, what performance counters were, how it was about the memory, CPUs, concurrency of the threads, blockings, deadlocks, many other things in the database. So this is the thing that's really crucial. Really, database monitoring is what we need for troubleshooting such issues. And that's also our product that we can deliver. Just the information from the logs is useless about some things. Or you need to invest a lot of time into analyzing that and find something about the root cause. If you have the monitoring, it might be much easier, and it's most crucial for us. Why I'm still talking about that setup? Because if we look at the database overview, we have 3 databases, independent ones. We have more than 3,000 tables and 170 historical data entities where we are pumping those data. And if you imagine that for one day we may collect 300 million of rows in one table of historical data, the database grows really terribly. And if someone changes, as I said, from 7 to 30 or 60 days, it's a huge difference. A huge difference for everything, for the engine itself and also for the requirements on the writing the queries and testing that. You can have tiny installation with 50 gigabytes for some very local installation, but you can have 3 terabytes and even more. And then it starts to be challenging, not just for us, but also for DBAs of the customer. How we can scale? Everyone heard about scaling up. We can add more CPUs, we can add more RAM, but just to some extent. Once you hit the capacity of your hardware or some limits, SQL is not limited from the CPU point of view, but what is limited is your money, how much you can invest into that. It is extremely expensive if we are talking about Enterprise Edition with all the features without any blocks, without any margins. So simply, that's not it. That will not help you. Scale out to buy another SQL, no one will invest into that. Sharding with the MSSQL server is extremely pricey thing. It's not a cloud. Scale out, adding other instances might be good for cloud, for the services, but not for SQLDB. That's not the way, at least not for us. No one will pay for that. You can optimize. You can tune or adopt new technologies or features. I will mention details about those things, and I hope at least about some of them. What helps us? We have some features and technologies that we applied. One of them that helped us a lot, mostly with the historical data, because this is the pain for us, is the table partitioning. It's not anything new. It is there for years. There are many things. There are many ways how to do that. It improves the data management because real table partitioning, the enterprise one, was formerly available only in the enterprise edition of SQL. Since SQL 2016 SP1, it's everywhere, even for Express, Web Edition, and for Standard. So you can use it. It helps you to manage the data because you have one table. If you had partition views before, you need to create a table for each day and bound it within a view. So instead of one table, you can have 60, 100 objects in the database with one entity. And that might be really terrible for execution plans and other stuff. So handling and managing partition table is much better. You can hit one partition and defragment it, for example, or you can take data from it and put it into some table instead of working with all the tables. So it improves the maintenance, query performance, many other stuff. But just the partitioning will not save you. That's just one step in a long way. There are 2 basic partitioning types. One is the vertical partitioning. This is the screen above, the picture above, where we can split table with many columns into more tiny pieces. For example, based on the frequency of updates. Common database is based on row indexes. So longer row you have, you need to read it into the memory, and you need to work with that. And you have blocking, with isolation levels that are given. So if you split it, you might manage it much better, and you might get much better performance due to the fact that you are using different methods for updating, for changing the data, and for selection. Everything is bound into the view, so it works perfectly for the selects. You don't need to change any select statements, for example. Horizontal partitioning is the way we use for the historical data. So you can use, or you can create a partition for each month, for example, if you have sales. For us, it's not enough. We need to have a partition for each day. One day is one partition, and that's how we do it. And we work with it in this way because of the numbers we have. We have frameworks for that, because doing this, 170 historical tables, 3,000 tables in total. Everything managed by the scripts. It's absolutely unbelievable. It cannot be done. So we have some frameworks that are helping us to maintain this and to deploy tables based on the metadata and to manage them. Some funny things about the partitioning. SQL is limited to 15,000 partitions per table. And we have some functionality where we get the date from thing we called collector. And for example, when the Linux computer is restarted to the default, it is using 1st of January 1970. So when you receive such date and create all the partitions until now, you hit the limit. And you don't have any space for the current data. And we had such things because the component on the customer side simply was restored to the Linux default. Or 1st of January, year number 1, same thing. And funny thing with the Microsoft functionality, if you merge one partition, that means you remove it in Microsoft way. It takes a couple of milliseconds. But if you do it for 50K partitions, it takes hours. So there is probably another bug, not yet reported from my side. Some good practices, if you are doing partitioning, never use same partitioning function and schema for multiple tables. Have it for each table separately. Otherwise, you may have blocking, or you need to be sure that you prepare all the tables with the same parts without the data, for example, if you need to merge partitions or split them. How that may work? We have detailed data here, partitions per each day in some file group. We have another one in hourly data and how we can put data into there quickly, not by selects directly. It's better to prepare a temporary staging table, for example, by the select. When we have it, we add the same indexes as are in the target in the hourly table. You need to add a check constraint to be sure that the data are matching the range of the partitions you defined, and you switch it in. It's in a couple of milliseconds. Insert will take you hours. And you have no blocking, because about the staging table, no one else knows, just the function or store procedure that is operating with that. And at the same time, with the transaction remove part from, you have it in hourly and remove part from detail, so you don't have a duplicate if you are selecting the data. That's one of the ways. Another thing is column store. Anyone heard about column store indexes? Anyone use them with SQL or with any other engine? No? It's there since 2014, I think. In 2016, available for all editions. So column store index is physically stored in columns instead of rows. There is much better data compression. Our experience is 3 to 10 times. Depends on the data you have. If you are working with numbers, short strings, dates, great thing for that. If you are doing analytic queries. Analytic queries mean you are using, for example, rank over partition by minimum, maximum, average, standard deviation, some calculations. But it's not good for fetching the data. Like, I need to select these 10 rows and return them. It's not for those operations, but for the numeric data, for the historical data, for the time series, it's great. One thing you should take care about, delta store. Delta store is part of the table, and it's a common B3 index. It is used always when your bulk insert is less than 100 to 40, I cannot read it, this number. You can also avoid it if you are using switching partitions. That concept which we have. If the delta store is involved, it's a little bit slower because there is a job on the background that is moving it to the column store and compressing the data. So when you need that, be sure you do not have tiny bulks or use something different. Collect the data into the staging and then switch into it. Memory optimized tables, I already mentioned. Why we need them? If we have really problems with the concurrency, this is the way where to go. If we have the blockings that cannot be handled by simple transactions, by something else, and simply we cannot push into the system so much as we need, this is the right way. There is no locking. It uses optimistic isolation level, read committed snapshot, or snapshot in this case, sorry. There is very high transactional throughput, so you will see improvements very, very soon. And you have no problem with deadlocks. There are collisions, something else you need to care about. If you have problems with the fragmentation, index fragmentation, because your indexes are not constructed properly, or simply the operations you are doing with the data are leading to the fragmentation, memory optimized tables has no fragmentation. No need to worry about that. But it is consuming memory. If you have the bottlenecks, you can try. You can also leverage natively compiled store procedures that are in C#, in C++, natively compiled into C++ and very fast for some. What we can do as other thing is maximizing parallel processes and operation, but it starts with the scheme, with database definitions, with how many files you are using, how many file groups you are using. If you have some fine setup like instant file initialization, autogrowth, maxdop, and other things, tempdb must correlate with all those. I'm just... Mohl bych dostat ještě 5 minut? Anyone interested, or should I stop now? What do you think? What is the most crucial component that affects this DB performance? What hardware component of the server? You are right. Storage. No memory, no CPUs. It's about the storage. Yeah, rates are there for sure, but SSDs... right, also the write, and with the concurrency of the operations. Reading can be done in buffer pool if it is cached, if you have enough of memory. But the problem is when you need to sync the changes. And that involves disk a lot. So for us, it's about disk latency and throughput, not about IOPSs. You can have very high IOPSs, but if you don't have the throughput and the latency, and we need 1 to 2 milliseconds. If it is more than 10, we can see performance issues. 100 is a killing option. And also the network, mostly in case if you have availability groups and replication, because it counts in every transaction. In that case, transaction is committed when it is persisted on the last secondary replica. And networks and the storage counts in. And the last from these three is memory. The difference is how we are accessing historical data. Insert, truncate versus insert, update, delete. If you plan to do deletes with the deletes and updates with the historical data, do not do that, because it will be a never-ending blocking for you. With the extents I told you, 300 million records every day, billions of records in a table. If you haven't it partitioned, it will be running for hours, days, without any chance to push any data into. So insert truncate is the way for us. Insert as it is, as it was polled, never change it, just remove it based on the retention period. If you have partitioning, you can truncate the partition of a given day. That's everything, no delete. So you will take all the day and remove it. In milliseconds, no delete. Some good practices. Never implement foreign keys on historical data. If you delete something on the entity, and then that delete will be triggered automatically, the cascade delete, it will be run forever. Not a good way at all. And some orphaned records, like if you remove the component, delete related data from historical tables. So much costly that it never pays off. Optimization and tuning, something about concurrency. You know that there is optimistic, pessimistic, read committed versus read committed snapshot. Read committed readers are blocking writers. So if you do not use that evil no-lock, you have no chance, not with our data. So showing the dirty data in reports, it's a common, but we are not changing historical data. So no way, no problem with the no-lock hint, with the dirty reads. Locking, blocking, deadlocks, probably known for you, but some funny things, deadlocks cannot be done or cannot be generated only by interaction of some sessions that are fighting for the same lock. Deadlocks might be also on the storage level. If the storage is slow and you have full transaction log full of transactions that is not able to persist it on the disk, you have the deadlocks. And even bulk insert can be in a such way if the SQL is not able to do anything. Very weird thing, but we had seen it. Bulk operations. Chunk processing is not a good way. One big transaction for us is better than doing something on the background for a long time, because we need to do it quickly. Something like the chunk size and doing something with 10,000, 5,000 rows, not good for us, at least from the maintenance perspective. Maybe good for some lazy upgrades that are running on the background, but not if it is deleting or updating something. One big transaction is usually better. Bulk operations, not just bulk inserts. Example with the chunk processing, this is some procedure that we run. It was running for 530 seconds. When we changed it to one transaction, it was done in 90 seconds. So six times improvement just with removing the chunks and reducing the blocking. This is example of bulk operation, and everyone had seen it. Doing things ID by ID and executing 5,000 of such things. You will kill your database. Do not do that. Do it as update join. Collect data, for example, into the temporary table, into variable table, join with it and delete or update. It will be much less blocking. And last thing, if I may, is the database maintenance. Do we really need to care about such thing? Database maintenance. Are you doing that? Yeah. We really need to do. We have some daily jobs, common things that are implemented everywhere. Index defragmentation, consistency checks, backups, statistics updates, something you need to care about to have the working system and to have it properly working. If your statistics are out of sync, queries will not be running good and optimizer will not generate proper execution plans for you. So you might have huge performance degradation. And some things are also here configuration related, like transaction log file and data files management. Auto growth matters very much for the transaction log. How many VLFs inside? Huge change. Also, the status of the health of availability group might be here as another job. What we do is index defragmentation and statistics updates. The rest is on the client. We have just somehow to what they should have, because we cannot manage that. What we can manage is index defrag and the statistics. And the other part is not about the database, it's about the data. You need to have your data in valid structures. So you need to have also a valid data. Prepare new partitions, prepare new tables, do the data aggregation from detail to hourly, from hourly to daily, because we are using, for example, 3 data granularities. And some things like removal of stale data, old data, and data consistency checks. If you don't have foreign keys between the entities due to some logic, you should care with the store procedures or with something else, what will give you really valid database schema. Just very basic examples about that. Any questions from your side? I know it was very fast, right, and there was a lot of things, and 25 minutes is not enough for that.
Thank you very much.
Thank you.
So, questions? Yes?
You said many different rules, and it's really hard to understand all of it. how do you ensure that all the developers follows those rules? Because it's really hard to have all of them in
We have the frameworks for the historical data mostly, where the developers define the structure in C# code, and the rest is done by the stored procedures on the background. The tables are generated from the metadata as well as all functionality around. And that's the main goal. The problem is the old stuff that is manually written. That is not yet migrated, and that's really a tricky thing, because everything is written in a different way, as another guys here, different rooms were mentioning already. So it might be a mess, but the frameworks are the way for us, automation of this type. We have 2 internal frameworks for this, for the database, finally. And yeah. No. The framework has its own stored procedures. C# just declares it on the C# side, puts the metadata into the database, and stored procedures are doing everything with that. So it's a combination. C# is more here as a wrapper and as a declaration.
Anyway, we can stop here. Thank you very much again for your presentation. You will be here, I guess, for a couple of minutes.
If you would like to get in touch and ask for anything after the session, please.
Yeah, you can speak Czech later, maybe. So maybe it will be easier. So thank you again very much for coming.
Thank you.
And thank you for coming too.
Thank you for your time.